My story idea here with warming winters and effects on snow across the Great Lakes and the Midwest, it was generated by a coworker who had just a simple question. Is the rain snow line moving north across the country? So how would you respond to that?
Right. So the first thing I would say is that this question that you're posing for this region, I think it's important whenever we talk about a regional question to recognize that this question is important at continental scales, and it's relevant at global scales. So in other words, there are individuals, citizens, news agencies, and researchers trying to answer this type of question all around the world right now in the midst of a warming climate. So I think that's a really important contextual piece. In terms of answering the question about changes in a snow line, one of the key words that comes to my mind in explaining what's happening is variability. There's a tendency to want to look at how we experience changes in climate and the weather and try to draw or imagine in our minds long-term trends based on what we experience. And to be honest, in the Great Lakes region, especially in the areas of northern Indiana, northwest Ohio, what we're experiencing in terms of temperature and snow, I believe, is actually pronounced or is described, best explained more by variability in some cases than a long-term trend. It's not that there isn't a long-term trend in temperature and precipitation, but the amount of variability is really extraordinary. Let me just give you a quick example. When we put together temperature data for the region that we're talking about right now, we see a long-term increase in temperature, especially in the winter times. But if you are trying to plan for any given winter, in terms based on this trend, you'd be surprised when in 2014 we experienced an Arctic polar vortex deformation or the Arctic polar vortex. So when we look at these long-term maps of temperature, it honestly, Nicholas, it really does look like a bunch of up and down lines through which way you can draw a trend line that is going up gradually. But I really think it's important for this region to understand the importance of interannual variability that we think is going to continue in the future.
I think that's really important too. When we talk about maybe looking out to the end of the century, 2080 to 2100, what are our expectations there, for winter season, for snow? Where are we going?
Yeah, well, in general, where we're going, and it's important to know that the results that we're based on here are not just based on what I do, they're based on work that my colleagues do, and a lot of other scientists in the region, including partners in federal agencies like NOAA, the National Oceanic and Atmospheric Administration, and even the Army Corps of Engineers. The models that we project into the future are suggesting for this region two clear signals. One is that it's going to be getting warmer, especially in the winter seasons. But the second thing that's really important is that we're actually going to be getting more moisture coming into the region. I'm sure you've heard this before, but for a lot of our audience, it's important to remember that warmer air can, in general, hold more moisture. So the warmer air that's coming into the Great Lakes is carrying with it, a lot of times, more moisture that's getting dumped in the Great Lakes region. So what that means is that we're likely, first and foremost, to get more moisture water coming into the Great Lakes. But because it's going to be chronically getting warmer over time, more of that increased moisture coming in is likely to fall and stay on the ground as liquid rather than as solid in the form of snow. And that's what we're expecting to see in the long term going into the end of the century.
Do we believe if we line up all the elements just right, if we line up the cold air with some of these, warmer origin systems, and we get that heavier wet snow, and we are able to really churn out that moisture as snow, are we still in line for some big snowstorms?
Absolutely. Absolutely. And this goes back to the point about variability. It's going to take a long time for there to be a complete absence of really heavy snow events. And one important point in this, Nicholas, is when we talk about the sources of moisture for this unique region where we live, it's not just the oceans, which is the common source of moisture for many regions of the world, but we have the largest surfaces of fresh water right in our backyard, and they are continuously going to be a source of moisture. So this idea that this idea that, different sources of moisture can contribute to the water content of snow, we're always going to have the lakes as a source of moisture right in our backyard. And for that reason, it's reasonable to believe that we'll continue to have snow events with that heavy, moist snow.
So my snow-loving viewers who are living in despair, this season and the thought of warming climate, a warmer climate, they don't need to fear that they're going to be living snow-free lives.
Well, there will be less of it for sure. There will be periods when it comes back. I think the hardest thing that I and a lot of my colleagues who do modeling and simulations and look at data will be that it's going to be much harder to predict and plan for when those will happen. Certainly we might get a snow event that is worthy of skiing or recreation, but it might happen at a time that isn't convenient or we didn't anticipate, either too early in the season or too late in the season, relative to what might have happened, in the 60s, 70s, and even in the early 80s, when we would have these major snow events that would stick around for a longer time period. So I think that's an important takeaway from all of this.
What do we see happening to the length of the snow season?
Yeah, great question. So a lot of the research that we're doing right now has been on the total amount of snow in any given season. So I've got to be honest, I don't have a great answer right now in terms of the sort of the timing of when snow melts. And part of it is dictated by this variability. So I think in this region, one thing that we are seeing is, regardless of the total amount of snow that falls throughout a season, we are seeing a pattern where snow is more likely to melt throughout the course of the season. So instead of having one poignant moment in April 1st, which is common in a lot of mountainous regions, the snow is melting intermittently throughout the season. So, in effect, you could have the same total amount of snow in a given year, but we are finding that it's melting intermittently more throughout the course of the season. That's important, not just for recreation and for our snow-loving viewers and our audience. It's also important for ecosystems that rely on flows and rivers and streams at certain times. And it also changes the overall hydrologic cycle, where we don't necessarily have a peak of inflow into a system in the spring, that the water that's melting is coming in a lot of cases more gradually. And that has important implications for how people live along the shoreline. And like I said earlier, for ecosystem and aquatic habitats.
Now, you mentioned a little bit about the Great Lakes. Talking about lake effect snow, here in Northeast Indiana, we do, for some of our counties, get some of the influence of lake effect snow drifting in here. How does that play a role when it comes to warming winters?
Yeah, it's very, very complicated because just to outline it just briefly, the factors that go into driving lake effect snow include, the temperature of the lakes, whether or not they're cold enough to even have ice on them, the temperature and the moisture or the humidity of the air that goes over the lakes. So typically, conditions that would be right for lake effect snow are when the lakes are relatively warm and the air is cold and dry. And then a lot of that moisture from the lakes will transfer into the air. That air will then pass over the land. And when the land is cooler relative to the lakes, it precipitates. So there's a lot of, you can imagine, there's a lot of variables at play there, right? The temperature of the lake, the temperature of the air, the temperature of the land, not to mention the direction of the airflow over the lakes, which in this region is also complicated because of the jet stream, right? Which can perturb and go in different orientations throughout the course of any given year. So there's a lot of factors at play. That being said, a lot of the scientists that we work with have indicated that lake effect snow events might, in fact, in some cases get more intense. If you looked at what's been happening in Buffalo over the past decade, there have been extraordinary lake effect snow events. And a lot of that comes from the fact that the lakes, sometimes in the late fall, can be very, very warm. And we can still get outbursts of cold Arctic air that can come over the lakes, pick up a lot of moisture, and then immediately over the cold land, dump it right on top of cities like Cleveland and Buffalo. So I think that's a reasonable synthesis for what's happening and what we're likely to see in the future as well.
Has there been any research into the texture of snow and the nature of the snow as we warm? Are we more likely to see wet, heavy snow versus the light and fluffy stuff?
Yeah, That is a great question. So we have two scientists on our team, one who's with me right now, Dr. Joy Shin, who's a postdoctoral fellow, and then another graduate student, Therese Hopp, who are both looking into this right now as part of a long-term project, looking at Great Lakes water levels going out for the next century. And this is being conducted in partnership with NOAA and the Army Corps of Engineers. It's active research right now, so I don't have a great answer for you in terms of how that texture and that composition is likely to change over time. But it is something that we're actively looking at because it is critical to the hydrologic cycle, and in this case, to future water levels.
Can you tell me more about all the research that you're doing that relates to this story, your findings, what you're looking for? I'd love to learn more.
Sure. So our group here at the University of Michigan works with a strong network of partners, like I said, across these federal agencies, the Army Corps, NOAA, other academic institutions. There's another group that we interact with called the Cooperative Institute for Great Lakes Research, or the acronym is SIGLR. It's a partnership between NOAA and the University of Michigan. And this group together has been doing research for decades on Great Lakes water levels. And this is something that's sort of core to the research we do. So to put more broadly, we do research at understanding the amount of the water supplies to the Great Lakes and how changes in the amount of water coming into and leaving the Great Lakes through evaporation translates into changes in water levels. I think another key point of this, Nicholas, is that this work builds on not just a binational partnership, which many people think of between the United States and Canada, but it actually really warrants a multinational perspective. We're right now engaging the perspective of a lot of sovereign nations throughout the Great Lakes region. And we've just launched a brand new center called the Global Center for Understanding Climate Change Impacts on Transboundary Waters. And one of the main themes of that center is to focus on the Great Lakes region and understand how climate change is going to translate into changes in the hydrologic cycle, into water levels, and how those changes are going to impact people's lives and decisions about how they interact with water.
On the overall scale, obviously those are big topics, lots of findings and lots of findings to come. But for life in the Midwest, even if we're not talking about winter, just talking about our water and water supply here in the Midwest, are there any important messages to share with our weather watchers about your insights and your findings so far?
Yeah, so I mean, one thing, I don't know if this is directly answering your question, but I think it's a good opportunity to say that, a lot of the research that we're doing in the Great Lakes and connecting it to other areas has to do with hazards and quality of life and human health and safety. So a lot of the colleagues that we work with in climate science and hydrology, they're concerned with things like massive floods, landslides, hurricanes, tornadoes. One thing I will say is that despite some of the changes we're seeing and what we traditionally think of as a quality of life in the Midwest in terms of ice cover and ice fishing or snowmobiling or recreation, all in all, the quality of life in this region is relatively high compared to some of the hazards and the climate impacts that other regions are facing. One of the important areas of research that isn't just an area of research, it really is an important management decision, is what might cause people to stay on the Great Lakes and continue to do their jobs and live here? What might cause more people to come to the Great Lakes under the auspices of what we might call a climate refuge area? This is a really important question because in the big picture of things, the climate here is relatively benign and amiable. And I think that's an important message. I will mention one thing underlying this, though, which is even though we're in an area that's relatively temperate, even though we're in an area where some of these climate hazards seem to be relatively small compared to some other regions that we hear about in the news, and even though we have what we might think of as a relative abundance of water in terms of quantity, we have to be so careful about the quality of the water in this region, especially this area of northern Indiana and northern Ohio, the sort of post-industrial area where there's a lot of legacy pollutants in our groundwater. I think this area, in addition to paying attention to the things we've talked about, is going to have to be really careful about how we take care of the quality of our water for the next several decades. Because even if we have a lot of water, if that water is contaminated and it's causing human health problems, it's not going to make the Midwest, and in particular Northwest Ohio and Northern Indiana, a desirable place to live.
Thanks for sharing that, because I think that is one thing that our local weather watchers hear when we talk about climate change. Sometimes they don't it's hard to draw those connections because we're not on the coast. We're not dealing with sea level rise. So sometimes the impacts and the questions of how is this going to impact me, those are common questions around here.
Yeah, and certainly don't get me wrong, for our audience, these climate change impacts in the region are extraordinary. The diminishing ice, right, and these changes in snow. But it's important to remember that we live on a pretty big continent with a lot of people who are experiencing a lot of different impacts of climate change. I think it's important to remember those different perspectives.
Now, one final question, getting back to winter. When talking to non-scientists about what warmer winters will mean to life in the Midwest, what do you say to them? What are the important takeaways for people just on the topic of winter?
Right. It's hard to come up with any singular takeaway, right? Because I guess the takeaway would be that we're probably going to experience sort of increased variability, right? Some of the extremes that we've seen in the past are probably not going to go away. And even some of the conditions that we're used to experiencing, shoveling snow away out of our sidewalks and our driveways, clearing off our cars, and driving in hazardous conditions, especially those under lake effect snow conditions. They're not going to get away. They're not going to go away, but the frequency with which they occur is likely to change. And so I think a good takeaway message is just because an event becomes less frequent doesn't mean that when it occurs, it won't have just as much of an impact, and we shouldn't be prepared for it. That makes it really hard because now we're in a world where we need to prepare for a wide range of extremes that are even harder to anticipate. But I think that's part of the reality that we're facing as we move through the century.
All right, great. Anything else you'd like to add in?
No, I do want to make sure that I thank, in addition to the partners that I mentioned and the federal agency partners, we have a wonderful team here at the University of Michigan. I want to thank again my colleague who's with me, postdoctoral fellow Sapelo Shin, as well as many members of our research team who help make all this work possible.